Hello, nice to see you all. So, thanks for coming, everybody, to this International AKU Patient Workshop here in Liverpool. So I'm Nick. I am the Chair and the CEO of the AKU Society. I've met many of you, but not all of you, so we're really pleased to be doing this. We haven't done an international one for a while, actually. So just a few things really, just before we start, a few housekeeping things. One is just to let you know, there is no fire alarm test planned today. So if there is a fire alarm, take it seriously. And there are forms to fill in for people who would need assistance to leave the building. Okay, so you would have to fill out a form. Obviously, people would still assist you if you don't fill out the form. There's what was I going to say? So a few things also. We have these bags, okay, and I know a lot of you want more than one bag, but just leave the ones that are lying around because we are expecting more patients this afternoon, okay? So that would be good. Good, okay, so what I'm going to do over the next 15 minutes is tell you really a little bit about, the AKU Society, what we've been doing, about the research that we've been doing here in Liverpool for more than 20 years now, about why we're doing this particular workshop here in Liverpool and stuff, and to update you on how things have gone, particularly for nitisinone, and then to tell you a bit about the other research that we're doing and the other AKU societies around the world. I think we have at least 10 of them now. And then to take you through the programme really, because it's going to be an exciting 2 days. You know, you're going to hear a lot about AKU and mental health, AKU and diet, AKU and movement, the latest research, children and AKU and all those kinds of things. So really the journey for me started, in 2000 when our first son was born, and, you know, we took him back from the clinic and we noticed that his nappies were going red-black, and we called an emergency doctor who tested for blood and didn't find any. And then he said that it's because my wife, Sonia, who's here, had eaten red cabbage. And that had somehow gotten into the breast milk, into the child, into the urine. And we thought, well, that's absolute rubbish. So next day we went to see our GP, who sent off for a whole bunch of tests to Great Ormond Street. This was late 2000. And he then invited us in, and he told us, look, your child has got this rare disease called Alkaptonuria. And we were like, well, how do you write that and how do you pronounce that? And then he said, whatever you do, don't go on the internet. And obviously that's exactly what we did. And at the time, I don't know if even Google existed in 2000. It was Yahoo, and we went onto a Yahoo group. And we came across a patient called Robert Gregory, who used to live in Liverpool, who sadly has passed away since then, and spoke to him and all that, and spoke to a number of patients, mainly in the US at the time. There was quite an active group in the US. And then Bob said, look, I've been speaking to this doctor called Dr. Ranganath, now Professor Ranganath, who I don't think is here yet, but you'll be hearing from him. And we're setting up an AKU society, and would you like to join? I was like, well, absolutely, you know, this sounds really good, you know. And so it was registered in 2003, but really, as a lot of you know, the origins of the AKU society come back, of AKU, really come back to this chap here, Sir Archibald Garrod in Liverpool, who's really a hero, I think, in rare diseases and genetic diseases, because he was the first one to show that any disease could be inherited. Because up until then, people knew that diseases could be contagious, but not that they could be inherited. And he developed this whole theory of inborn errors of metabolism, which he published in The Lancet in 1908, and it was these lectures, the Croonian lectures. And Alkaptonuria was the first disease that he identified as such. So it's really quite astounding, and he was at least 50 years ahead of his time, And we now celebrate Garrod Day, which is really kind of his birth and all that, to kind of celebrate what he's done for us. But really quite an astounding character, And because of that, AKU is in all the medical textbooks. So when we did 15 years ago, we did a survey of all GPs in the UK to try and identify AKU patients. We got thousands of responses, and 20% of them could remember AKU from their medical textbooks. It was just somewhere in the back of their minds. I remember that one. It's the black urine stuff, isn't it? You'll all know that. The urine, the ears, the eyes, and then the black bone, basically, which is why we also call it black bone disease, which is kind of easy to pronounce for most people than Alkaptonuria. You'll all know the metabolic pathway. I won't take you through the science of it all, but really that's where Alkaptonuria is. So it's basically, as you know, due to mutations in a single gene, which means that this enzyme, homogenesis 812-dioxygenase, either doesn't form or doesn't form properly. And so, you know, all of us with Alkaptonuria develop this substance, homogenesic acid, at 2,000 times the normal rate. And that binds to cartilage and bone and goes black in this process called ochronosis. And the wonder drug here is nitisinone, which some of you are on. I don't know if all of you are on it. Quite an astounding drug, developed in the 80s as a weed killer, you know, which is really quite amazing. And the guy who really discovered it, Professor Ted Locke, is one of our advisors. He's based here in Liverpool. And it was developed, really invented by some professor who was gardening and noticed that around his Australian bottlebrush plant there were no weeds, and he identified the compound. And they synthesized it, a company called ICI, this huge conglomerate, in the 80s. They never actually commercialized it as a weed killer because it was too potent, and the plants went yellow as well as killing the weeds. But there is a similar substance called mesotrione, which is the second most successful weed killer in the world, you know, which is also an enzyme inhibitor that works like nitisinone, just not as strongly. And you can get that in any garden centre. So anyway, nitisinone was then developed for that disease, tyrosinemia type 1, thanks to Ted Locke, you know, who really pushed the company to try and develop it very successfully. And then in the late 90s, a guy called Dr. Bill Gall at the NIH published a letter in a scientific journal saying, can we now use nitisinone to treat Alkaptonuria? And some of you, I think, might have been on the trial they did 20 years ago at the NIH, which unfortunately failed because it wasn't enough patients, and they were looking at a single endpoint, which was hip rotation, and it failed, and that nearly killed the whole thing, you know. So in 2009, Professor Ranganath, myself, and Professor Jim Gallagher. So this is basically urinary homogenesic acid. You can see it completely clears with treatment from nitisinone. Quite dramatic. And this is the AKU mouse, which is here in Liverpool, and which you'll hear more about, I think, tomorrow. But you can guess which one is Alkaptonuria, you know. And mouse research is really important because before you can actually test in humans, you have to test in mice. And when the mice are given nitisinone at birth, they don't develop any symptoms of the disease. And when they are given it halfway through life, it completely halts the progress of the disease. So it's a great model, and we're testing things like mRNA therapy and other therapies in this mouse model. This is the academic research we've done in Liverpool, so we have a very strong link as an AKU society with the group in Liverpool for a number of reasons. One, obviously, there's Professor Ranganath, co-founder of the AKU Society, who's based here. But now, for the past 12 years, there's been the National AKU Centre. There's Leanne, there's Helen and Emily, and other people here from the NAC, which is really just a wonderful treatment centre for AKU. And then there's the team at the University of Liverpool, with who we've been working since 2006. So you can see there was a post-mortem, which is an autopsy of a patient, which was published. A cell model, and then a natural history study. There's a number of patients who came along, and then Professor Ranganath studied how AKU is affecting them, and that allowed him to put together a score which allows us to score over time how AKU is developing in patients, which is crucial. Then the mouse model, then the National AKU Centre. This is the number of patients we know at the moment worldwide, 1,325. Obviously it's a rare disease, 1 in 500,000 roughly, but we do get hotspots. And we'll be hearing tomorrow from Martin about the registry that we've launched, which is an international registry. This is really important. If you're a patient and you're not on the registry, get onto the registry, because this allows us to monitor how AKU is affecting you in detail, and will help us with development, and also hopefully will help us gather data to help those who can't access nitisinone access it in their countries. So the registry is absolutely crucial. This is all the AKU societies. If I've missed one out, come and see me at the end, and we will add them in. But these have all been set up by local patients and also local scientists and doctors in different countries. It's really important that people set up local AKU societies and get them registered, because this helps you with a number of things. It helps with research, it helps you with access to nitisinone, because then you have a formal body that can interact with regulators and all that in your country. And it also helps us if we try and get nitisinone into your country and all that, because it helps with interaction with the companies who are developing nitisinone. This is the National AKU Centre. centre, the Royal Liverpool University Hospital. Really just an amazing centre for us here in the UK. This was the launch in 2012. That's Bob there in the wheelchair, who sadly has now passed away. And you have key people there. The one on the left is Professor Ranganath, really important, and then Professor Jim Gallagher, also on the right, and we have Jonathan Jarvis there also. Jim and Ranga will be around. And then the clinical trials, I'll take you through these briefly. But, you know, we did this from 2012 to 2019 with a large grant from the European Commission. The clinical trials cost 11 million euros in all. We got 6 million from the European Commission and then the other from a whole range of other sources. I really need to sing the praises of the European Commission. Without EC funding, we'd have never done this. There is no national body, whether that's in the UK or in other countries, who provide the scale of funding needed over the length of time needed for ultra-rare diseases like this. You know, it was really amazing. And it was a ton of work. I mean, Ranga and I spent the whole of Christmas and New Year in 2011 putting together a 140-page application for this, you know. And we ended up scoring 15 out of 15 for it. Out of 550 applications to the EC, we came first, you know. So we were really pleased to get the funding. This was the consortium we put together. So it was led by the Royal Liverpool University Hospital as the main coordinator under Ranga. You know, without someone with the strength of character and passion of Ranga, we'd have never done it. Every Thursday morning for 7 years at 9:30 in the morning, all members of the consortium would have to join a teleconference. This was pre-Zoom days, apart from if it was on Christmas Day or New Year's Day. That was for 7 years. And if you didn't turn up, Ranga contacted you and said, why don't you turn up? You need to turn up to these things. Because managing a consortium of 13 organisations is really hard. So really thanks to Ranga, who I don't think is here yet, for running this. Without him, we'd have never managed. So those were the members. We had also the AKU site in Alkap. We have Pierre Goyot from Alkap here. Just here, who's taken over from my parents over the past few years, so we're really pleased about that. And then, you know, we had the Hôpital Necker in Paris, who were amazing, and the National Institute of Rheumatic Diseases in Slovakia, who were amazing too. And then the company Sobi, who were absolutely terrific. You know, it was really great to work with them. They were fantastic. And then the University of Liverpool and others. This was the consortium when we met in 2019 in Siena. This was our last meeting. You know, so you can see there's quite a few people there. You know, it's really quite logistically difficult to put all this together. And in Liverpool, so in France they were seeing French and Belgian patients. In Slovakia they were seeing Slovak and patients from Jordan. And the team in Liverpool was seeing patients from all over Europe. You know, so that was a real testimony. And Emily and Helen were the nurses who ran things from here. So thank you, Emily and Helen. You know, it was really an amazing experience over 7 years. And those were the studies. So there was Sonia 1, suitability on autism and Alkaptonuria 1. That's called a phase 2 study. That is a study in humans where you try and find the best dose. And then that was over 3 months. Then Sonia 2, suitability on autism and Alkaptonuria 2. That was a phase 3 study, which is the big study before you get regulatory approval. And then the Sophia study, that's to find out what age did the actual damage start, you know, and actually we found that from age 16 we were seeing little spots of ochronosis in the eyes, you know, and it didn't go lower than 16. We're actually now trying to get some funding to do a children's study, but that's proving quite difficult to raise the funds for that. Those were the clinical trial sites, Liverpool, Piestany and Paris. This was the Sonia 1 study, so you can see it was 0 milligrams, that's placebo, 1, 2 and 4, and that's the reduction in homogentisic acid. So really quite spectacular, 99.4%, you know. Really quite spectacular. And then that was rounded up to 10 milligrams because this was a liquid formulation for the Sonia 2 study. And in Sonia 2, it was 99.8%. So the target was 70 patients off nitisinone and 70 on. I'd say a big thank you to all the patients who went onto the non-treatment group, you know, because that was really difficult for 4 years, you know. And they did it for the wider community. You know, so that was really huge. They were randomized to that, and some of them had been randomized to the non-treatment group on the NIH study, so they were like, oh, you know, but in the end it was worth it. It was absolutely worth it. So in the end we recruited 138 patients over 9 months. Apparently this is the biggest ever study of an inborn error of metabolism ever carried out, and there's hundreds of inborn errors of metabolism. And what was amazing, I remember when Ranga looked at the data with the team at Sobi, it was all very confidential because, you know, you're not allowed to tell everybody. It has to be, you know, they're very strict rules on how you do this. And then actually, I remember him ringing me up when they'd looked at the data and he said, it's just amazing. We've reached statistical significance in the severity score index, which was really even more than what the regulators had asked us for. The European Medicines Agency, the regulator, for the UK, we were still part of it. This was pre-Brexit. The EMA were fantastic, absolutely fantastic. They really understood rare diseases, and they were fantastic. They approved it very rapidly. And then the European Commission gave marketing authorization in October 2020. So this was huge, absolutely huge, for a drug that was a weed killer, approved for one indication, then this, and actually it's now being developed as an anti-malarial for all kinds of reasons. It's really quite an amazing drug. So yeah, that was absolutely fantastic. But that was just the one part of the journey, because then we had to get it approved in every country. It had to go through the different reimbursement agencies, and I think there's only one country left in Europe where it's not been approved for reimbursement, and I think that's Romania. And so we're doing all we can there. But every other country, I do believe, in Europe and the UK, it's available. And in other countries, I think in India it got approved a year ago, and I think other countries. The big challenge now is the US. And there's a company called Cycle Pharma who do a generic version of nitisinone who are trying to get it approved by the FDA. But the FDA is a real pain in the neck, to be perfectly honest. But hopefully that will be approved soon. So, you'll recognise some of the patients here. This is what they said. These trials give us great hope. This dream completely changed our lives. We're that one step closer to a cure. So the current research we're working on, and I'll be very brief here. One is tyrosine inhibitors. So you'll know that when you're on nitisinone, your tyrosine goes through the roof. And we have some amazing dietitians who are going to be speaking today, Claire, and also tomorrow, who are going to explain how to go on a low protein diet to keep your tyrosine levels under 700, which is really important because otherwise you can get problems with the eyes, corneal crystals and all that, skin rashes, and things like that. So it's very important to keep your tyrosine levels down. So we're working on tyrosine inhibitors, and these are drugs, so small molecules, that stop the absorption of tyrosine in the gut and all that. And we've done some preclinical work. We've worked with 2 pharma companies on this with quite spectacular results, actually, in the mouse model. The difficulty now is getting the funding to continue to get it into human trials, but we're working on that. So that will take a few years. If all goes really, really, really well, within 5 to 6 years, one of those could potentially be approved, but medical research is really tough, so you never know. mRNA therapy, so this is using the kind of technology from the vaccines, okay. In AKU, we've been doing a project over the past year and a half, with some mixed results so far, to be perfectly honest. We need a bit more money to do some more research into that, And gene therapy, that's at planning stage, and that would be potentially a cure. But for a gene therapy to be approved in AKU, it has to be 100% safe. So anyway, that's further down the line. So a bit about the programme. So on the back of your thingamajigs, your name cards, you've got 2 QR codes. One is for the survey. So please do answer the survey tomorrow when everything finishes. It's really important. And the other one is the agenda. Okay. So if you scan it in, you then get access to the agenda. I'll take it through very briefly. So obviously, welcome Dr. Nick from now. Then you'll have a controlled protein cooking demonstration from Nutricia, which is really useful for all of you who want to learn how to cook low protein diets. And then Claire, who's our NAC dietitian, will talk about diet and Alkaptonuria. Claire's over there. And then that's for Group A. So you'll see on your cards it says Group A or Group B. So depending on which group you are, you'll be in different rooms, okay? And then we swap over. Then after that, we have Steve Smith from Rare Minds. Rare Minds are a social enterprise company who do mental health for people with rare diseases. And Steve Smith, who's a counsellor there and psychologist, will be talking about mindful-based approaches for chronic health conditions. So this is really helpful to help deal with the chronic pain in particular and some of the isolation that we have when we have a rare disease like Alkaptonuria. And then we'll have Martin from Dendrites who'll be talking about the registry. As I said, that is super important for everywhere in the world because this is what helps us gather data about AKU to understand the disease better, but also to help you in your country get access to treatments. And then we have a focus group from VitaFlow later today. So VitaFlow provide low protein and all that, and we'll be providing more information about that. I think that's for today. And then we have a 3-course dinner this evening here at the Holiday Inn, which we're really looking forward to. And then tomorrow, Juliet, who's a lecturer of anatomy, did her PhD on AKU, who's going to be talking about the research. She's been at the University of Liverpool, and then we have Brendan, also from the University of Liverpool, that the AKU Society is funding his research. We'll be talking about the tyrosine inhibitors that I just mentioned today. And then Nutricia will be giving an update on their products and services, and then we'll have a breakout session from Sean Williams, a Pilates instructor, all about Pilates, also to help with your AKU. And then another breakout session, this will be on AKU in children, and we'll have Professor Ranganath talking about the latest research into understanding AKU in children, and then Claire will be talking about what happens when you come to the NAC as a, when you reach age 16, etc., 18, whatever, and then you get access here and stuff like that. And then we'll have Jim Fish talk about water exercise for AKU, and then Ranga will be giving a 1-hour talk about the history of AKU, which is utterly fascinating. From an Egyptian mummy at the University of Chicago that clearly had AKU, all the way to what we know today, and then we'll be closing. So just a few things. 3 people that I really, if you haven't met them, I want you to meet. One is Leslie. Most of you will know her. So Leslie recently retired after 12 years at the AKU Society. So Leslie has been really the pillar of the AKU Society for the past 12 years. So yes, thank you to Leslie, And then we have Hannah, who started a month ago, who's taken over Leslie's position. So do get to speak to Hannah if you get an opportunity. And then also Natalie, who has really helped us organise the whole thing. I don't know where Natalie is, but she's absolutely fantastic, So expenses reimbursement. We've managed to get some money to help you with travel. In the UK, I believe, if you've travelled from the UK, we can provide up to £100. If you're travelling from Europe, up to £150, and outside Europe, up to £300. So after the workshop, we will send you forms to fill in, and I really ask you to make my life as easy as possible. Please fill in the forms, okay? Don't just email me loads of receipts. Fill in the forms properly. We need your full bank details so we can do the transfers. That means name of your bank, address of your bank, your name, your address, your IBAN, if you're international, your SWIFT, your BIC, if you're in the UK, your sort code, your account number. Fill in the form properly with reference, scan in all your receipts, and when you fill in the form, you put in the cost in your local currency, and then you convert that to the UK, and then you put a total amount in UK pounds. Please make it as easy as possible for me, because it's going to be a lot of work. And when we did a workshop a year ago, some scientists, you could say, it was just a bit all over the place, So there we are. If you have any questions about that, please come to see me and stuff. But yeah, thanks for coming. We are so pleased to see you there. Some people have been already asking us when's the next one. It will probably be at the earliest in 2 years' time. It's always dependent on funding. And the funding for this came from a number of sources, including actually the National Lottery in the UK. So thank you. And I'll now hand over to... I think now it's the cooking and the diet.
Can everybody hear me okay? Yeah. I don't know, I wanted to try and keep this, I'm Claire by the way, and I'm the dietitian at the National Alkaptonuria Centre. I wanted this session to be quite informal, so I don't know if people want to move forward a little bit, and then, if you want to ask questions as we're going, if you've got any queries, please feel free to come and sit closer to the front. If you want to stay where you are, that's also fine, but it'll be nice just to have this as a conversation rather than me just standing up here and giving you a lecture. So, quite a few familiar faces and quite a few faces of people that I don't know. So I'm guessing you're not from the UK. So nice to meet you all. As I say, I'm Claire Salisbury. I'm the dietitian at the National Alkaptonuria Centre. I've been a dietitian for 35 years now, so an old dietitian. I've mainly worked in hospital dietetics in critical care and intestinal failure. I've also worked in academia. And 3 years ago, I took quite a change of direction and joined the National Alkaptonuria Centre at Royal Liverpool Hospital. So I have 3 years' worth of experience in Alkaptonuria. It's been a very steep learning curve. I'm still learning, but I will share my knowledge with you today. And as I say, if you have questions, please just put your hand up and ask as we go. You don't need to wait till the end. Okay, so what I'm going to talk about is dietary management at AKU. I'm going to talk first of all about how we do things at the National Alkaptonuria Centre. I'm aware that most of you will be under different dietary regimes to us, so if you're happy to talk about what you do in the countries that you come from, that would be really interesting. If you're not, no pressure at all. I'm going to talk about protein and protein requirements and where protein requirements come from. And then I'm going to talk about the strategies that we use at the National Alkaptonuria Centre for people that have high tyrosine, with some of the evidence for why we do that, so that even if you use a different dietary regime to us, you can maybe understand what the principles of what we're trying to do. And if I'm talking too fast or using too many technical terms, do tell me. Okay, so I tend to walk around a lot when I talk, but I'm going to have to stand still because I've got a microphone in front of me, so that's going to be really difficult. So at the National Alkaptonuria Centre, we use nitisinone, and we use anything from 2 milligrams. We're actually using 2 milligrams alternate days in some of our patients, up to 10 milligrams. So the National Alkaptonuria started using nitisinone about 12 years ago, and patients were given 2 milligrams off licence. Obviously, then the licence came in at 10 milligrams, but a lot of our patients prefer to stay on a 2 milligram dose for a number of reasons, but primarily because it gives a little bit more dietary flexibility. We use what we call a controlled protein intake, so we don't use a low protein diet, we use a controlled protein diet, and that's based around I've got 0.75 to 0.83 grams per kilogram. We can call it 0.8, so it's around 0.8 grams of protein per kilogram, and that's actually the recommended intake. So for most people that'll be about 40 to 65 grams a day, depending on their body size. So people feel that they're on a low protein diet because we eat a lot more protein than we need, but that's actually based on the recommended intake for adults. Okay, so because it is a controlled protein intake and we want people to keep to the protein levels that we've set for them, we use strategies to manage protein intake, and we use something called protein swaps or protein exchanges. Does that term mean anything to anybody? Familiar? Lots of faces go, ooh, including the UK patients, so that's interesting. So what we do is we count the protein in the food, and we use what we call 7 gram swaps and 2 gram swaps. So the 7 gram swaps, each portion of food there contains 7 grams of protein. So it's all based around an egg, because an egg has 7 grams of protein. But that's the same amount of protein as in 25 grams of meat, or 200 mils of milk, or 125 mils of yogurt, or whatever else you choose to use. And we also use protein swaps for the carbohydrate foods that most people who didn't have AKU and don't know about diet and protein would think don't contain protein. But because we're monitoring the total protein intake, the 2 gram protein swaps are the protein that you find in things like bread and rice and pasta. So again, those foods all contain 2 grams of protein. So if you were on a 65 gram protein diet, you would be allowed around 7 of the 7 gram swaps and around 10 of the 2 gram swaps in a day. So that would mean you could have 7 eggs, or if you wanted, you could have 2 eggs, 50 grams of meat, 200 mils of milk, a yogurt, and I can't remember how many swaps I've used it, but don't judge me on my maths. And if you were having 10 of the 2 gram swaps, you could say have 10 slices of bread, or you could have 2 slices of bread, 60 grams of pasta, 150 grams, until you've used up. Does that make sense now? Yeah. So in the old days, we would divide up, or in the old days until about now actually, we divide protein into high biological value protein and low biological value protein. So the high biological value protein is generally protein of animal origin, and it contains all the essential amino acids. The low biological value protein is low in some of the amino acids. And we used to say that you had to have 70 grams of protein, 70% of your protein from the high biological value and 30% from the low biological value to make sure you got all the essential amino acids. The guidance now is coming out that we don't need to do that anymore. The guidance is actually telling us, because what happens when you eat protein, you break it down into amino acids. That's how it's absorbed into the blood, and they're the building blocks of protein, and your body doesn't care whether the amino acid came from a cow or from a piece of broccoli. So we actually are moving away. It's just your total protein intake. It doesn't matter. I used to say, you've got to have more of the high biological value protein. But we're moving away from that and saying you just have to have protein. Okay, we don't count the protein in fruit and vegetables at the National Alkaptonuria Centre. So except for things like peas and sweet corn, they're considered free foods. And in some of our patients, if they need additional protein, we'll use a tyrosine, phenylalanine and tyrosine-free protein substitutes. I'm going to talk a little bit more about those later. We don't use them in everybody. We have about a third of our patients, I would say, are taking those, but they're taking them in quite small quantities, usually only about 20 grams of additional protein. And we aim for tyrosine below 700. We don't actually achieve that an awful lot of the time. I think our average tyrosines are probably in the 800s, but we're aiming for around 700. You might find in the centres you work at that actually the aim, I think quite a few centres aim for below 500, so might be a little bit stricter than we are. Okay, I'm going to keep going. Any questions, do just stop me as I'm going. All right, so dietary management of tyrosine in other of AKU in other countries, I actually don't know. So if anybody here is happy to say what happens where, you know, in their centres, that would be great, but only if you feel comfortable. I think most places are using 10 grams of nitisinone. Is that 10 milligrams? Sorry, of nitisinone. Is that no? 2 milligrams? Yeah, 2, 5, 10. Yeah, a mixture, 10 in some places, so varies. As I say, we have some patients who are on 2 milligrams alternate days, some take it even less often than that. The majority of ours are on 2 milligrams daily, and those that want to increase, we're increasing to 5 milligrams initially and then up to 10 milligrams. But we are finding with the higher doses that the diet does need to be a little bit more controlled, and a lot of our patients have become quite relaxed. They probably don't use protein swaps or anything else, but you do need to have some way of controlling your protein intake on the higher doses. Okay, so in places that are using 2 milligrams of nitisinone, are you using low protein diets, or are you using similar to us, what we call a control protein intake? Yeah. Anybody using really low protein diets? Yeah. Okay. There's a few people using low protein diets. Yeah. So we use a control protein intake, and so the others are primarily using control protein intake, so about probably 40 to 60 grams of protein per day. Yeah. And then I've also heard some places are recommending plant-based. Yeah. Yeah. Plant-based, yeah. Excellent. Okay, so we've got a mixture. Hopefully I'll be able to talk to all of that. Okay, so how much protein do adults need? So the UK dietary reference value is 0.75 grams per kilogram. The WHO guidelines, and I think what they use in Europe, are 0.83, yeah, or 0.8. But generally, we're talking about 0.8 grams of protein per kilogram. So if you're 65 kilograms, then that's about 50 grams of protein per day. Yeah. And these are based on nitrogen balance studies in primarily young, lean individuals. So there were various nitrogen balance studies, but one of the big nitrogen balance studies was done on conscientious objectors in the United States, conscientious objectors from the Vietnam War. And what you do in nitrogen balance studies is you take the protein intake right down and then gradually increase it. At the same time, you measure all of the nitrogen. Nitrogen is another term for protein. So when I say nitrogen, just think protein. You measure all the protein that's coming out of somebody. So that's the feces, the urine, your snot. They had them in hazmat suits. So all the cells that sloughed off would be hoovered out at the end of the day. So you measure protein in and protein out. And when they're at the same level, that tells you somebody's protein requirement. So that's nitrogen balance studies. And as I say, these were primarily in lean individuals, so probably quite different body composition to us. And what they did when they did all these nitrogen balance studies, they found that there was an average protein intake. There was an estimated average protein intake. So that, if I've got a pointer on here, that's the middle here. That was the average protein intake. But what they found is that some people had protein requirements that are very much lower, and some people had protein requirements that were very much higher. So the problem is if you go for the average, you're only going to meet the requirements for 50% of the population. So what they did, and this is a statistical term, they used 2 standard deviations above the average to say that this is the reference nutrient intake or the recommended intake, and that's the 0.8 grams per kilogram. Okay, that should meet the protein requirements for 97.5% of the population. So it should meet all of our requirements as adults. So So for some people, it'll be a little bit more, people who've got, because this is your typical population curve, your bell-shaped curve, with most people in the middle and then outliers at either end. So for most people, it'll be a little bit more than your requirements, but it should meet the requirements for everybody. Okay. So nitrogen balance, I said, is protein in versus protein out. And nitrogen balance has been criticised in certain population groups. So if we look at nitrogen balance as a diagram, now this is quite confusing, so don't worry if you don't get all of this. But what nitrogen balance is the blue. It's protein in versus, oops, where's my clicker gone? Protein out, okay? So just look at the blue. So your dietary protein compared with your fecal and your urine losses and the little bit that you lose from your skin and your snot and everywhere else, okay? What's actually happening inside the body is that protein is being broken down to amino acids, which amino acids, as I said, are broken down and then reconstituted into different kind of protein in the body. Some is used and some goes back into the bowel as enzymes. And what isn't needed, because we can't store protein, we use protein for muscle building, and it has a lot of other functions in the body, protein. We talk about muscles because that's what we're interested in, and probably wherever your dietitians, whoever will measure your, I measure the lean body mass of my patients to make sure that we're maintaining muscle mass. But protein has many other functions. It's used in hormones, enzymes, structural things like hair and nails, also used in lean. So we can, we can build our muscles, which increases the amount, but we can't actually store protein. So excess protein that we don't need, what happens is the carbon skeleton of the amino acid, the amine group is taken off and it gets excreted in the urine, and the carbon skeleton is converted to either energy or fat and stored in the body. So, but what we're just looking at protein in, protein out, and what nitrogen balance isn't doing is it isn't looking at any of what's going on within the body, and that's why it's being criticised, because in certain groups of people, you're using more protein within the body, and nitrogen balance isn't looking at that. So the group of patients that really it's been criticised that nitrogen balance isn't accurate enough is primarily in the elderly. It's also for inpatients. With another hat on, I'm doing a very large systematic review at the moment looking at protein requirements for sick hospital patients, and because we know nitrogen balance isn't particularly reliable for that patient group, we're actually looking at studies where they've measured different protein intakes and looking at different outcomes, and we're looking at something like 16,000 papers at the moment. So that's my weekends and evenings for the next couple of years taken up. And also in the elderly, we think that nitrogen balance, because protein metabolism is different. This is quite a complicated slide, so don't worry if you don't understand all of it, but I'm just going to talk you through it, and if you just get the basic principles. So what we've got here is the stomach. So we eat food, including protein, and it goes down to our small intestine where it's broken down, and then amino acids circulate in the blood. At first, they all go to the liver, and then from the liver, they circulate around the body, and ultimately, some of them will arrive at the muscle and be used for muscle protein synthesis. So what happens in patients like the elderly, or people like the elderly or sick hospital patients, is that the liver and some of the other abdominal organs pick off more of the amino acids. So there's less of the amino acids going to the muscles. And then what also happens, because we make muscle after a meal, and then in between meals we break muscles down, and after a meal, we make muscle as a stimulus from amino acids, but also what happens after a meal is muscle protein breakdown is suppressed so that we get better muscle synthesis because we're making it and we're stopping the muscles from breaking down. And it's insulin that is one of the things that suppresses muscle protein breakdown. So in the elderly or in sick patients, we have insulin resistance. Insulin doesn't work as well. So what we've got is we've got less amino acids arriving at the muscle, and we've got less suppression of muscle protein synthesis, so we've got lower muscle synthesis in the elderly in a patient population. These models are still slightly hypothetical because it's very difficult to measure protein requirements. What they've done is they've used amino acid tracers. So what they do is they trace an amino acid with a stable isotope, and they measure the blood that arrives at a muscle and measure it after, or they can use biopsies. So there's a lot we still don't know, and some of this and some of the other things I'm going to show you are sort of hypothetical models, but we think that the disordered or the less protein amino acids arriving at the muscles kicks in from sort of mid-50s onwards. So yes, quite early on, and that's why we see something called sarcopenia, or lower muscle mass, possibly in the elderly. And you certainly, having worked in critical care and with sick patients for most of my career, we see muscles really depleting. So if you are building muscle, you do need a little bit of extra over that. The amounts are quite small. So if you were going to gain about 10 kilograms of muscle over a year, which would be a lot if we was going to increase my muscle by 10 kilograms, then because muscles are about 70% water and 30% amino acids, that would mean you'd need about 3 kilograms or 3,000 grams of muscle over a year. So that would be about 8 grams a day. Now, when we're going to the gym and we're doing work, we probably break our muscles down a bit as well as build them up. So even if you were doubling that, you're probably only looking at about 10 to 16 grams a day. So that's about, depending, if you're 65, it's about 0.3 grams per kilogram. So it's a lot less than people think they need. And because we've got a bit because the 0.8 is probably more than, you might even have enough in there. But yes, potentially, for athletes, you would need more than that. But for people who are going to the gym a few times a week, then it's probably accounted for within your requirements, or a little bit over and above that. Does that make sense? Yeah. Okay, so protein requirements. So we use 0.8 grams per kilogram for most people, but that might be slightly higher in the elderly, and as I say, over 55, which most of us might not consider ourselves elderly over 55. Disease or metabolic state. So obviously I've worked in hospital for years, but if you were to go into hospital and needed surgery or something you probably need to think about a little bit of extra protein, and athletes for slightly different reasons. The other thing I just wanted to touch on is that quite a few of the patients that we have at the National Alkaptonuria Centre are either overweight, so BMIs over 30, and also we have quite tiny people that only weigh about 40 or 44. And when we assume a linear relationship, so 0.8 at whatever weight, then we're probably giving too much protein to people who are overweight and probably not enough to quite little people. So we do an adjustment factor. One of the things in the big systematic review we're looking at is how much we should adjust for, and there really is no data. So I do a bit of a guesstimate, and we don't know how accurate there is, but probably requirements are more. This is a hypothetical S-shaped curve, but that probably shows you what protein requirements are. It's not a straight line. Okay, does that all make sense? Question, yes, Saeed. So you do need slightly more protein, and I'm going to talk about this tomorrow at the paediatric workshop, but yes, during growth, requirements are higher, probably 0.9, 1.0, 1.1 grams per kilogram. So actually the requirements for an adolescent boy is higher than it is for a man. So yeah, so you do need extra, and also for pregnancy as well. So protein is made up of, you'll see 22 amino acids. The extra 2 are probably not particularly involved in human metabolism, but we have 9 essentials, so they must come from the diet. Phenylalanine and tyrosine are found in all protein-containing foods, and they're used to make up to manufacture serotonin, melanin, and thyroid hormones, amongst other things. I'll just see this. I'm more than happy to share slides with anybody if you want me to. I'm more than happy to email. I'll do them as a PDF, but I don't mind. So if anybody, save you having to take photographs, I'm very happy to share my slides. Okay, so this is a slide. Oops. Hate these slides. Okay, the arrows should be going both ways here, but if you remember what's happening in AKU is you've got phenylalanine is converted to tyrosine. So phenylalanine is your essential amino acid. Tyrosine isn't essential, it can be manufactured in the body, and they ultimately go to homogentic acid but blocked by nitisinone. So what we see is because the hydroxyphenyl pyruvate is quite unstable, we see a buildup of tyrosine. We can also see a phenylalanine increase. Just remember where these come from. Phenylalanine is an essential amino acid, so it comes from the diet. But tyrosine can come from phenylalanine, it can come from the diet, or it can come from endogenous production. It can come from muscle with it, or from protein within the body. So in PKU, you can get the phenylalanine is quite low in a low protein diet, but it's a lot more complicated with tyrosine because tyrosine can come from a number of sources, not just the diet. And I apologise, there should be two-way arrows, so I'll have to update that slide. So, dietary protein. So these are the protein-rich foods, most of them high biological value. You've got lentils in here, so lentils are not classed as a high biological value because they're slightly low in methionine, but they're a protein-rich food. And then you've got the foods that most people don't think of as protein, but because you have AKU, you will know they do contain protein. They contain less protein. But you've got fruit and vegetables. Fruit and vegetables do contain protein. We don't count it. I've got the protein table somewhere. They're relatively low in tyrosine compared to the others, so we don't count fruit and vegetables. And then we've got, these are a VitaFlow product. There are other products available. There's the Nutritional, so these are the Thai coolers. So these are manufactured to have no phenylalanine and no tyrosine in. So at the National Alkaptonuria Centre, with our control protein intake, we base our diet on these things. Most of the protein will come from these, some of the protein from here, and that should total between 40 to 60 grams per day for most of our patients. For patients who need extra protein, either because they're a little bit overweight or a little bit small, or because they're older, or because they just seem to need, some people just seem to need more, we add in the tyrosine phenylalanine-free protein. We normally add that in. We don't take this protein away, we add it in as an extra, and that usually brings the tyrosine levels down quite well, but sometimes we may need to go for a low protein intake. Elsewhere, people who are on low protein diets will probably primarily on vegetables and fruit with small amounts of the plant-based protein, or maybe the low protein varieties, and then most of the protein will come from the tyrosine phenylalanine free products, and that's a diet they use in PKU as well. I'd say we're using these proteins primarily, and only these if needed, but if you're on a low protein diet, you'll be on these and you'll be avoiding these. Does that make sense? Yeah. So summary then about protein requirements. Most adults need about 0.8 grams per kilogram, but may need adjustments for the elderly, extremes of BMI, and if protein requirements are higher than that, then we'll add in the tyrosine phenylalanine-free protein substitutes. So what I was going to do next is just talk about what we do at the National Alkaptonuria Centre to try and manage the high tyrosine levels that we do quite often see. Let's be honest about it. Okay, so first of all, that one's not come out. Okay, so what's on this slide that you can't see is what patients do is they submit to me a diet diary. So for the annual review, we do a 7-day diet diary. And what we do on that 7-day diet diary is I look at everything. I look at not only the protein intake, the protein spread, I also look at the micronutrients, things like calcium, vitamin D, things like vitamin B12 and iron, to make sure the diet is adequate. And what I do is we break it down so as we can see the protein content of every food that somebody eats, and then we look at how much protein it is, and we look at the spread during the day. So I'm really sorry that that hasn't come out, but it will be somebody's intake for the day with so every food: milk, tea, biscuit, banana, breakfast cereal, other kind of breakfast cereal, every food broken down, and I've got a package that will show me the protein content of every food so that we can see exactly where the protein's coming from in the diet. Okay? And normally what I do is I circle the protein swaps on it so that people can see where the protein's coming from. What has become very apparent to me is that although we use protein swaps to count, or protein exchanges to count the protein content of food, I think I'm the only one who does that. There's a few people that do it, but I think most people don't get protein swaps or don't use them. I think, would that be a reasonable summary if anybody wants to agree to me? I think that's partly because a lot of people have been using them for years, so understand the protein content of their food, and also look at food labels. I think there's a fair degree of guesswork goes on as well, which is absolutely fine. What we've done in recent years is we started using an app. We use Nutritics, other apps are available. Nutritics is a really good app, we particularly like it. It's one I use to analyse diet for my patients as well, because it uses foods from the government database. So these foods they're all validated. We've got, as well as the protein, I can tell the phenylalanine, the tyrosine, all the intake of all the different amino acids, and I can tell the intake of all the micronutrients as well, so we can make sure the diet's adequate and all of those. Whereas if you use something like MyFitnessPal or one of the other apps that are widely available, they just use food portion sizes, food labels, so they're not as accurate. But Nutritics really, you have to pay for it, so we pay and the patients get the app for free. And it probably only uses the database for the UK and Ireland. So if you're not living, it won't have the right kind of manufactured food. So there will be other apps in the countries that you come from. But we've done some work with the app, and we found that the patients that used it found, because you can track your protein as you go. So you don't have to worry if it's not a whole swap or half a swap, it just tracks your protein as you go. And so people who used it found that it was much quicker than filling out a diary. They found that they understood the protein content of food quite well, and they could juggle their food around. And I have some people who use it, they literally track everything. It's like their security blanket, and they track everything that they eat. Some people dip in and out of it if they want to find them, then don't bother because they know what they're doing quite well, and then they might dip in a bit. So, and quite a lot of people don't use it, but for our patients we've found, especially for our younger patients who are quite used to using apps, it's something we've found a really useful addition. And it's great because if it's in the app, it saves me a bit of time analysing the diary as well, because those diaries can take hours. Okay, so we look at dietary adherence, and what I would say is for people, certainly if you're going on to a 10 milligram dose, you do need to be tracking your protein. So you can use swaps, you can use food labels, you can use the app. But if you're going on 2 milligrams, you've probably got a bit more flexibility, but on 10 milligrams, you really do need to be monitoring your intake. So we look at dietary adherence to make sure that people are having the right amount of protein, or roughly the right amount. But we also look at the spread of protein throughout the day. Now this, as I said before, a lot of the stuff about protein utilisation at muscle level is based on some knowledge from amino acid traces, but this is a hypothetical model. It's not, it's a hypothetical model of what we think is happening. And we think of our muscles as quite, my muscles, but they're actually turning over. So our muscles are turning over all the time. We're in a balance between muscle protein synthesis and muscle protein breakdown. And the turnover is huge, probably double what we're eating, maybe 80, 100 grams of protein per day turning over in our muscles. So on this diagram, you can see the blue is muscle protein synthesis. So we've got the metabolic stimulus, which is a meal with some protein in, and we go into muscle protein synthesis. Between meals, it breaks down. And then we have another meal when we build muscles and break down, etc., etc. What we've got going on at the same time is muscle protein breakdown. So what's happening in muscle protein breakdown is red. It's suppressed at mealtime because we have the release of insulin. It increases between meals and then goes down again. Okay? So this shows your sort of typical Western diet where you have a bit of protein at lunchtime, at breakfast, more protein at lunchtime, quite a big protein in the evening, and then no protein overnight, so you've got that overnight fast. Just a few things to point out here is that there's something called the muscle full phenomenon. So the muscle can only take so much protein from a meal, and then it becomes satiated. So if you think about it, you've got people who are eating tons of protein, and they're not walking around with muscles like that, are they? Unless they're going to the gym and doing an awful lot of training as well. So the muscle can only take, and we think that's about 20 to 40 grams of protein from a meal. And the excess protein is then, the protein is deaminated, the amino groups go out in the urine, and it's converted to even energy and protein. So if you ate all of your protein at one meal, you wouldn't utilise most of it. A lot of it would just be used for energy, and it goes in your wee. I always call it expensive wee when people are on all these high protein diets. It's going into their urine and you get an expensive wee. But if we standardise this out and try and equal out the protein, it's about protein during the whole day. So if we try and equalise this out, and rather than have a similar amount of protein each meal, and even have a snack in the evening, then we're going to get more net protein synthesis. Yeah, does that make sense? We're going to be suppressing. So why do we care about muscle protein synthesis? So we care about muscle protein synthesis, first of all, because the studies show us that if you have better muscle size, better muscle function, that you stay healthy for longer. You know, you stay more active. If you go into hospital and you're not well and need to have surgery, you will recover from that surgery quicker, you'll get out of hospital quicker. So we know it's important to maintain your muscle mass, and those of you who come to the National Alkaptonuria Centre, that's why I measure your muscles every year, to make sure that you're not losing them, okay? But also we think it matters because when you're in muscle protein synthesis, you're taking amino acids into the cell, into the muscle. So you're taking tyrosine out of circulation. And when you're in muscle protein breakdown, you're releasing amino acids. So you're releasing all the amino acids in the muscle, including tyrosine. So if you have more muscle protein synthesis and less muscle protein breakdown, then in theory, it may help you get a better serum tyrosine level. Does that make sense? Yep. So that's why I ask people to try and, it's not only about the amount of protein you're eating, it's about the spread of protein during the day, because in theory, that will help give you a good serum tyrosine level, but also it will help maintain, you know, that small amount of muscle, that protein that you have will work harder for you if you're spreading it out. Okay, so, and in theory then, this is what we're doing, is we're seeing a more even spread. And for the people who have high, say the elderly, who don't metabolize protein as well, we can give you some extra protein in the form of the tyrosine-free protein, so that we're hopefully maximizing your muscle protein synthesis from each meal. Yeah. So, just a quick word on the tyrosine and phenylalanine-free protein substitutes. Have most of you tasted them? Yes, most of you have, some of you have. So we have the old kind. This is the Tycooler. I apologise if anybody from Nutritia is in the room. I haven't got this. The Nutritia equivalent is the Low Flex. And then what a lot of people call the pouches. These are the old style protein substitutes. So they're made, they would separate, they'd make all the amino acids individually and put them all together into a drink that doesn't contain phenylalanine and doesn't contain tyrosine. I think it would be reasonable to say they have an interesting flavour. You've got the new kinds which are based on glycomacroprotein, GMP. I don't know if anybody have tasted those. The companies are here and you can taste them. GMP is a byproduct of cheese production. It's kind of like it's kind of part of the whey protein. So it's a natural product. There is a suggestion that the amino acids might, or the proteins might be more bioavailable, easier to absorb because it's a natural product. But they taste... I didn't understand. Sorry. I don't think anybody understood what I was saying for half of the session, so you're not on your own. They have probably an easier taste. So there's two products on the market. It's a Tysphere, which is a VitaFlow one. So that's flavoured. It's got either vanilla flavour, strawberry flavour, and it's fortified with vitamins and minerals. So it's a bit like a milkshake. These products are virtually all fortified with vitamins and minerals, and that's because a lot of the patients, not AKU patients may only be taking none or one, but some of the patients who have maybe some of the other kind of the hereditary tyrosemias may be taking 3 or 4 of these a day, so they need the vitamins and minerals as well. The Nutritia, this is a new one, and it is just protein powder. It's not fortified with any of the vitamins and minerals. So as a result, it doesn't taste, because some of the B vitamins have got quite a strong flavour. It's a new product. We're using quite a bit of this. We're using it quite useful. So it comes in 10 gram sachets and you add it to a drink, and except for being a little bit creamy, you almost don't know it's not there. So a lot of you won't be on tyrosine-free protein substitutes at the moment, but I would say try them, because quite often when I say to people, oh, maybe it's something we need to think of, people say, oh, no, I've tried them in the past and they're horrible. But there are new products on the market, so have a look at what's available so that in the future, if you were to need one, you know what they taste like. Yeah, and they're all there. The stands are here today and tomorrow, so you'll have plenty of time. You don't need to all stampede in the next break. This is actually a slide, it's from the Horgan and Stubbs paper, which is actually on energy requirements. But I just want to talk a little bit about extremes of BMI. So this, you can imagine, this, I weigh 65 kilos, so you could imagine this is me at the moment. And based on my 65 kilograms, I would need 49 grams of protein. But my requirements for both protein and energy are driven by my metabolism. My metabolism, 60% comes from my internal organs. About 20% comes from my muscle, depending how muscle I am, and a small amount of fat isn't particularly metabolically active. So that drives my energy and my protein requirements. If I become overweight and I go up to a BMI of 35 and I weigh 95 kilograms, in theory, I need 73 grams of protein. But have a look what's happening internally. My internal organs might be working a little bit harder, all the reactions that are going on with my body, but not that much more. My muscle will have increased if I've put on weight, but most of my increase is due to fat, which isn't metabolically active. Equally, if I become really unwell and I lose loads of weight and I go down to a BMI of 16, a weight of 40, in theory I only need 32 grams of protein. But actually, my internal organs are still doing all that work and I've still got a reasonable amount of muscle. I've just got very little fat that's not metabolically active. So this isn't a straight line. Remember that S-shaped curve. So we do need to think about how we work out requirements at either end. And as I say, we don't have any evidence on that. I kind of do a little bit of calculation, guesstimate, and then we do, I don't always get that right. So we do sometimes need to play around with the protein quantities at either end of the BMI range. So these are the strategies, just a summary of the strategies that we use at the National Alkaptonuria Centre, am I right for time, to reduce serum tyrosine. So first of all, we look for dietary adherence, and we're looking for an intake of about 0.8 grams of protein per kilogram. We do adjust that for BMI, with my little fudge factor. But we're also looking for a good spread of protein. And I would say spread of protein is as important. And one of the things that I meant to say on the previous slide, and I forgot, so we'll just quickly jump back and jump forward again. The other thing I forgot to say is exercise. Exercise is probably as important as diet. It is joint-friendly exercise, so do be careful. But when you exercise, you're going into muscle protein synthesis, so you're doing the same as the metabolic stimulus from a meal. So exercise is really, really important as well. Sorry, I forgot to say that before. Because that's next on my list, is exercise if possible. So, and it doesn't need to be running a marathon, because we wouldn't recommend that because it's not great for your joints. It can be just keeping active, walking. If you're normally sedentary, getting up and walking around the room once every couple of hours, just keeping yourself as active as you can, because I know activity can become difficult for some people. So that's all around kind of dietary adherence. And if there is still a high serum tyrosine, despite all of these things, then we will think about adding in a tyrosine-free protein substitute. And we normally do that without, you keep on the same amount of protein, we just add the additional protein in. And the theory is that because of the various fudge factors that I've used, I haven't got your protein requirements just right, and we're just giving you a bit of extra protein. And that usually brings the tyrosine levels down quite nicely in the majority of the patients. Increased exercise, always more exercise if you can. If we still have high tyrosine levels after all of that, the only strategies left to us are either reduce the tyrosine, so we have some people who are reduce the nitisinone, so we have some people who maybe drop back from a 5 to a 2, or might go from 2 to 2 alternate days, or we can reduce the protein intake in the diet. But the low protein diets, for any of you who are on them, are really hard work. So we would, we have a discussion with all of our patients. It's an individual patient basis. We are led by what you guys want to do, and it's always based around a discussion. Sorry, I think I saw a hand go up there.
To take those tyrosine-free proteins, what is the best time?
Okay, so what I generally say with the tyrosine-free protein, it's another little burst of protein, so it's your protein stimulus. So I would say in the biggest gap between meals. So if you tend to eat your evening meal early, have one before bedtime. If you tend to eat late and you have a big gap in the afternoon. But generally, it also has to be when it works for you, because some people only eat 2, life happens, doesn't it? So as flexible as we can be, but generally the biggest gap between meals.
Or after exercise?
Yeah, there is an argument for taking your protein after exercise, because at that point you're incorporating it into your muscle. It is difficult though, because there's so many controls on what you can do. So I try and just in theory that matters, but in practice, so long as you're just taking them and spreading them out, it probably doesn't matter too much. Yeah. And This is a really good podcast. I put this up last year and said to everybody, this is a really good podcast. Anybody who was here last year, I don't know if you've listened to it. So Zoe it's a group of epidemiologists at St Guy's Hospital. I'm not saying that Zoe recommend quite a few things that I don't necessarily recommend. So I'm not recommending everything that Zoe recommends, but they invite speakers in to do podcasts about nutrition. Christopher Gardner's a bit of a hero of mine. He's Professor of Nutrition at Stanford University. And this just goes through about protein requirements and where they come from. It's set at a really nice level, and I listened to it again yesterday. I haven't listened to it for a couple of years, I think. And it's a really good podcast just about protein requirements. I would suggest you listen to it. Right, what I'm going to do now is we've got... Running alongside this, we've got a cookery demonstration going on. Now, the chef that we worked with and I developed the recipes with is sick and can't be here. So we have somebody called Natasha who's fantastic and has stepped in at the last minute. But she doesn't have a background in metabolic diseases. So I'm just going to run over there and see if there's any questions. And I'll do the same for you. What I would say is when we developed the recipes, what we tried to do was develop recipes where protein isn't the main event. So if, the typical Western diet is meat, veg, potato. With AKU on a controlled protein diet, if you do that, it's miserable because you'll have 2 little pieces of meat and it looks horrible. So what I try and get people to do is think about other ways. So if you have, say you have something like a risotto where you've got maybe a small amount of protein, it could be some meat, it could be some prawns or something, when protein isn't the main event, then you will find that a lot easier. Alternatively, if you use plant-based protein, because 7 grams of protein is an egg or 25 grams of meat, but it's 100 to 110 grams of beans or pulses. So if you can use a lot more plant-based protein, particularly the beans and pulses in your diet, your protein goes so much further. They're very healthy foods as well. So what the cookery demonstration is about is most of the food that she's presenting is low in protein or protein free. And then you can add your protein in on top of that. So it's trying to move away from protein being the main event. There's a number of recipes. She's only demonstrating 3, but Derek developed a few more. So I think those recipes will all be available. But I'm just going to run through to see if they've got any questions. I also have a lovely student called Kate working with me at the moment. She's not in the room yet. And what she's done is so we've got the menu that you're having for lunch today and lunch tomorrow and for the meal tonight. So she has analyse the protein content of it. So there will be some handouts, but we're going to put some slides up. I do recognise that a lot of you, when you come to stay in a hotel, have a holiday from your diet, and I'm not going to be looking. So don't feel that anybody's going to be saying you've got to be, but if you did want to keep to your dietary restriction, then we are providing you with the protein content so that to facilitate you doing that. Is that all right? So I'm going to run next door and swap with Kate, who's going to come in, and she's just going to run through. But I'll put up the first one. So this is the, I think, I don't know if anybody knows, that the lunch today is going to be a buffet. Is that right? Yeah. And lunch tomorrow is a buffet, and then the evening meal is a sit-down meal. So I'm just going to swap over now, and Kate will be in, and then I will do the same at the end, because you'll go into the cookery demonstration after the break, and I will run in at the end if there's any questions. Natasha, the chef, can answer questions about the cookery itself, but if there's any questions about sort of diet and AKU, I'll come in and answer those. Is that all right? Any questions before I go? Oh, my pleasure. Thank you all for coming today. I know we've asked questions as we go along, but other than the menu, because Kate will answer that, is there any questions just now before I run next door? So sort of your intermittent fasting, and it is a difficult one with AKU. We do have some people who do low carb diets and who do intermittent fasting. If people really want to do that, then I will work with them. So the idea behind intermittent fasting, or the evidence behind it, is really around weight management and also managing insulin resistance, because when we were sort of hunter-gatherers, we had periods of fast, and probably there is an element of that being good. The problem, here's Kate now, the problem with it with AKU and with the low-carb diets is that there will be some muscle protein breakdown during that period of time. But, we can do it with regular testing, but it's something that I wouldn't necessarily advocate for everybody. It can make the AKU harder to because of, as I say, if you've got long periods of fasting, then you are going to be going into muscle protein synthesis. And if we've got you at the minimal amount of protein, then it's regaining that protein again. But, you know, it's something that we can look at again in the future. But if there are people who really want to do that, then I will always work with people for what they want to do. Right, Kate, stage is yours. Is that all right?
Hello everyone. Claire's a bit of a tough act to follow. So my name's Kate, I'm a student dietitian. So I just calculated the protein in the food that you're going to be getting today for lunch and your meal tonight and for lunch again tomorrow. So I just calculated using grams of protein, or I'm not sure if anyone uses protein swaps. But before we get into the nitty gritty of all the figures, I don't know if Claire mentioned it, but we hope you enjoy your food, and don't worry, Claire's not going to be looking over your shoulder seeing what you're eating. So Big Brother isn't watching. So for lunch today, you're going to be getting the option of soup, and it's not made with potatoes, so there is no protein, so that's free. Then for lunch, it's a buffet style, so it's just a rough estimate of protein. So it's obviously, if you're having more scoops, it's going to be higher in protein. So there's chicken stroganoff today, but sauce is soya-based milk, so it's going to be obviously lower in protein. So the main protein is going to be the chicken, and it's around 16 grams. So then we have a vegetarian option of broccoli and spring greens pasta bake. This is made with Gouda and a spinach sauce, so it's around 14 grams of protein. And then you have your wild rice, new potatoes with like 4 and 6 grams. And then your fresh fruit salad, which is free. And then there's also options for sandwiches. So the protein is calculated including the bread and the fillings. So in this column here. So you have roasted red pepper and hummus, 11 grams of protein, falafel and beetroot, which is 15 grams, you have turkey, which is 15 grams, avocado and roasted tomato, which is 8 grams, and then you have your sweet treats, so your overnight oats, which is made with oat milk, so that's going to be lower than the whole milk, so that's 6 grams of protein. Your apple crumble made with custard from coconut milk, so that's going to be lower in the average protein, or average custard you'll be getting, and then you have your fresh fruit salad and cereal bars. I'm not sure in your handouts, do you have the lunch breakdown? I know you have for your dinner, so if you want to take a picture of that, there's no problem, or we can at the end. We can come back to it. So then your dinner tonight. So this is going to be served to you, so it's not buffet styled. So for starters, there's a trio of hummus with warm flatbread and roasted butternut squash. So that's kind of relatively low with 7 grams of protein. And then we have 2 options for the main course. You have butterflied chicken breast with new potatoes and Mediterranean vegetables. So that is quite high in protein, but if you have the willpower, you could just opt for eating half the chicken, but there's going to be no one judging here. And then the other option is cauliflower burger with roasted sweet potato and spring vegetables, which is vegan and gluten-free. And then dessert is chocolate orange mousse with coconut milk.
Sorry, the second option, I think you would have had to choose ahead of time.
Oh, okay.
So that's provided for people that have already asked for that option.
Oh, okay.
Everyone else is getting the same.
The
food.
chicken, okay.
For that.
Grand, okay, yeah. So then lunch tomorrow is quite similar to today. There's just different hot options. So we have the mushroom and spinach risotto, which is an estimate of around 10 grams of protein, but then again, if you have more scoops, it's going to be more protein, or vice versa. And then you have 5 bean chili con carne and rice, so that's around 14 grams of protein. And then grilled pineapple and cinnamon with natural yogurt, so that's around 6 grams of protein. Then the sandwich options are the same as today, and then the sweet treats are similar as well. So if you want to take a picture of that, but there's no pressure either way. So that's everything I have to say, and I'm sure Claire has answered all your questions, but if you have any other questions, work away. So thank you.
So Dendrite, we've been going for a little over 30 years, 33 years I think next month. We produce registries. We collect data for clinical societies, for clinicians. We've produced a little over 200 registries. They're in 50 countries around the world, and we provide them in 18 languages, including Mandarin, Japanese kanji, and Korean scripts. So that's, I say, our office. We've got a suite in that office block there, and we've got a back office in London where we keep all our techies. Usually throw red meat in there occasionally, the wild bunch. So, of those 200 registries, we started in cardiac, cardiothoracic. Some of you here may know that in the 90s there were some issues with heart operation in Bristol in the 90s. We were asked to produce a registry. That's now a mandatory legal requirement. All adult cardiac surgery in the UK is tracked. We started that registry. We go around the globe, out to New Zealand, where we do a breast cancer registry, a trauma registry, another cardiac registry. And we cover at the moment everything from A to V, allergies to vascular, and I'm still waiting for a Z. So let's pose the question, what is a registry? Well, quite simply, it's a posh name for a database, a medical database. So you're collecting data. In the traditional sense, the clinician would input data about their patient in a secure environment. Only the clinician can see their own data on their own patients. Outside that, it's totally secure. In this scenario, you guys will be putting your own data in and you'll have your own secure area. Another thing we'll do, I'll talk about in a minute, is patient-reported outcomes, where you can automate and put data in. Coming out of that are dashboards, reports, whatever, and this is one for Waldenstrom's, which I shall talk about in a minute. Waldenstrom's macroglobulinemia, it's difficult to say. So basically it's collecting observational data over a period of time. So within rare diseases, it's looking at specifically supporting you as a patient group to understand your disease and your condition, where it's going, and what can be done to improve outcomes and quality of life. With rare diseases, you're looking at a small group, so it brings together that data and you can see it, even with a small number of people. It can be used to augment or improve clinical trials, or where they're unsuitable. It can be used to inform bodies like NICE. So if a new drug was to come, you could collect data and you could go to NICE and say, here you go, this is why we need this drug or treatment. So what does it do? Well, it collects data on demographic data on the patient, on the conditions, on the comorbidities, the course of treatment, what drugs, anything, whatever is specified by the people that ask us to do that registry. There's unlimited follow-up data, and the problems, the patient-reported outcomes monitoring, I shall speak about in a second. So, PROMS is not part of your registry at the moment, but in a typical registry, we can send out a message, be it a text message or an email with a link that will go out, and it'll ask you to complete a form or some sort of thing. It can be as simple as smiley faces like you'd see in Asda or Tesco as you check out. Is it a good day or a bad day? We have a library of 40-odd standardised quality of life instruments covering all sorts of things. Mentions there the anxiety score for the Waldenstrom's, or clearly breast quality for the BAPRAS, which is breast reconstruction. Totally secure, totally automated, and is used quite a lot. There we go. So let's look at a specific case. Waldenstrom's macroglobulinemia. It's taken me a long time to say that. WM. Simplistically, it's a blood cancer. The history of this is there's a guy called Rory Morrison, who, anybody Radio 4 listeners here? No? Okay. Rory Morrison was a Radio 4 presenter who died of Waldenstrom's. He made a bequest to his clinicians and the patient group to set up this registry. It started about 2014, I think. Currently, there are over 1,600 recorded cases on there. And one of the first things that came out when we did this report back in 2018, the presumption was that Waldenstrom's was a disease of elderly white males. Wrong. Elderly white males self-diagnosed and self-referred. And within 18 months of the registry data, the whole hypothesis changed, and its onset from the 30s and it's 40% female. So that was the major change, just by collecting that data and looking at what was coming in. It uses the PROMs, the quality of life instruments, quite extensively, and it gets a high rate of return in the 70%. It's now in the third phase, having been supported by pharma companies, and that will become obvious in a minute. So the first phase, as I say, we got this change to what the perceived disease profile to the real disease profile came out. When they started, they had a scattergun. It was 18 or 20 different therapies, and it fairly soon became obvious there were a couple of first-line treatments that were popular and effective, and they focused down on those and focused on the results of that coming out. Then we have Janssen, had a drug approved, and they supported it as a second-line treatment, and there it's showing that in 70% of cases it's very beneficial. I've extracted this straight from their last report. So they're now working with commercial partners, which one would assume is Beijing, because they're funding it for this third round, looking at new therapies, and the aim is that the efficacy of that treatment will be measured, monitored, and presented to NICE to get approval for that drug. So, who's old enough to remember Monty Python? And now for something slightly different. There's something completely different coming along in a minute. So Castleman's disease, it's a lymphatic disease. They don't know if it's autoimmune or an infectious disease or a cancer. So right at the beginning of COVID, a lead clinician approached us and talked about this, and we put together a project. Now, the best way to explain this is to actually look at the diagram which produced it, or I think it is. I'm an engineer, so it is for me. I hope it is for you. So, in a rare disease environment, it's likely that a clinician, doctor in a hospital, will never see that case, that disease profile. And the case in point, my partner's got SLE lupus, and we had exactly this. Getting that first diagnosis was really difficult. So I'm a doctor, I'm in a hospital, I think, does this patient have Castleman's? So they have a website, you can go at that and look at that. If it's more urgent or you're fairly certain, you can actually register with your GMC number. 24/7, you can get a log on, you can put the details of that patient in. So within hours, you can literally notify this group that I suspect I've got a Castleman's patient. Some of these patients are in ITU writhing in agony, so this was quite important as part of this process. So we've sent a note to the admin. There's then a triage there. If it's urgent, they will get a phone call from one of 5 or 6 national specialists. Less urgent, they then go through to a national advisory panel, which is 4, 5, 6 UK national clinicians. They will have a Zoom call every 4 or 5 weeks, 5 or 6 weeks, with the local clinician who will present their case, that will be talked through, and they will then give advice, so that the advice that the treatment is being sent back out, the patient isn't having to come into a centre. And the local clinician can go around that loop as many times as they need. They're also recording the no-shows, the ones that aren't Castleman's, so they've got some idea of what the totality of that is. So, in preparing this presentation, I've got slight deja vu because I was here 2 weeks ago giving a very similar presentation to a different rare disease, but that's another story. So Matthew said, massive success. What's come out of this in the last 12 months is a consistent diagnosis of Castleman's at a national level. They're also getting these monthly support calls to support those local clinicians to treat it locally. They've got 45 confirmed cases of Castleman's so far that are recorded. They're seeing about 4 or 5 patients a month, and typically one of those is actually in ITU, which was the original foundation of this, that they could provide that advice quickly. So what's come out of this? Well, perhaps Castleman's is even rarer than they thought it was. They thought there's possibly 100, 140 cases a year. They've seen 45 so far in about 12 months of this running. But, question, is that because their one's going undiagnosed? Or are clinicians unaware? So those are 2 further thoughts that the registry could go down that track and try and explore that. Not quite sure. The other thing that's come out so far is that the multicentric form, so multiple lymph nodes, seems to be the more common one that's presenting to this team, and there are resource implications in that because this is the more complex form of the disease to treat. It needs more resources. So again, information's coming out of just collecting this data. And now for something really completely different. Nick has led us in a new direction. I'm very excited about this. I'm not going to tell you about AKU because you know more about it than I do. So this is a novel approach. So we've got our standard sort of clinician-led clinical registry. The second one was a support network. This is first person. It's you reporting on yourself. So like a clinician, you get your own area, which is totally secure to you. Anything that you put in there belongs only to you. And anything outside of that can only be seen in generalities. So obviously the aim is to gather data and to understand how the disease progresses. So apologies, these are massive eye charts and I can't even read them from here. But these I've just extracted from a monthly report that Nick receives from us and the team. So to give you some history on the registry, we first met with Nick's team at a Beacon Rare Disease event at the end of 2022. We engaged with discussions at Nick at the beginning of last year. We'd agreed the specification by about Easter, and we produced the registry during that 2023. Then the first quarter of this year was pretty much about the GDPR, and Nick, brilliant, glad to see this. This is what's called a patient information leaflet. It is key to making the GDPR process fully kosher. So you can see, and this is nearly 2 months out of date, September data, because I had to submit this a month ago. In that first 6 months, across 26 countries, you've had 66 people register to have an account on the registry, and from 18 countries, you've actually got 30 patients in there. Now, it could be that parents can have a child, so don't know. I can't see that data. I'm not allowed to see that data, but that's one of the things that could be looked at. Fantastic. Take the hat off to Nick's team. As I said, I was here 3 weeks ago, presenting to a group. I've been talking to that group for 4 years, and I think it'll be another 2 years before they make up their mind. Nick has driven this through in a year. So it's not a problem. Just needs decisive leadership. Thank you, Nick. So what do you do with the registry? It's me, that's strange, but anyway. So the first thing we advise people to is to think about what you want this report to tell you. So clear and explicit objectives, which is what I think Ranga helped Nick with significantly. We set up the data fields to support the objective of understanding AKU as the disease progresses. It must be easy to use. In a clinical sense, if we can't get a doctor to complete this in sort of 3 to 5 minutes, we don't get complete data. However, you guys have got a little bit more of a task. The first entry is 24 pages, but it gives you all the background stuff. It's a baseline. After that, it gets a lot less, and you see how your disease progresses over time. The more you put in, the more you get out of it. Hiding down there, I don't know why this has gone wonky, is attention to GDPR. Now, I've had some very interesting conversations already with some of our colleagues about the data protection on this. It is all fully in line with UK GDPR, Data Protection Act, which is fully aligned, harmonised, the expression is with Europe. So everything is as it should be in there. And I think that's thank you very much. Thank you for your attention. I'm very happy to take specific questions offline. I'm very happy to sit down and talk about it sort of outside this forum. But I don't know how long that's taken. 18 minutes. Sorry, it was meant to be 15. There we go.
Great. Thank you, Martin.
Thank you.
Great, thanks everybody. So this is the end of day one, but before finishing, just a few thoughts and a few comments. So on the registry, we had been really searching for about 15 years to set up a registry, since about 2009, and we were going round and round and round in circles. The reason, as Martin explained, why a registry is important, in medicine and science, data is everything. If you don't capture the data in an accurate way and in a way that you can then explain to people, it's very difficult to convince people about what you're trying to do, particularly in an ultra-rare disease. Now, the idea for this registry really came out of work that Professor Ranganath did 15 years ago when he did this natural history study. So you remember I said that nearly 20 years ago there was a clinical study of nitisinone at the National Institutes of Health that failed. And the reason it failed is the FDA insisted that Dr. Gall and his team only assess the effectiveness of nitisinone by looking at hip rotation, and if hip rotation got better. Now, as you all know as patients, some of you it's your hips, some it's your spine, some it's your elbows, some it's your knees, it's not always single hip rotation. So that showed nothing, despite patients who are on the drug raving about it. And that's when Professor Ranganath basically thought what we need to do is develop a composite endpoint. By composite, he meant that we need to look at every single aspect of AKU, so the spine, the eyes, the ears, the heart, the knees, the elbows, everything, score that into a single score, and then we can evaluate each patient every year. And if the score goes up, it means they're getting worse. If the score stops, it means that it's just stopping progression. And if it goes down, it actually means it's reversing, okay? And that was really, really clever. And he did that through two ways. One was through a survey with about 80 or 90 questions, and the other one was through clinical evaluations like x-rays and MRIs and heart scans and all that kind of stuff. So those are the two things that he did through the National Centre. So every year you go to the National Centre, Ranga and Milad basically look at this score, and he also did it through the clinical trial, the SONIA 2 trial, over 4 years. Now, the difficulty in a rare disease like Alkaptonuria that's very progressive is that you have to do a long study to prove anything. And that's where it is so difficult to convince a company to do like a 10-year study, because they're just like, it's too expensive. And that's why we had to do it on lots of patients, okay? Now, what came out of the National AKU Centre was that the score, the composite end score, over time, over 5 to 6 years, starts to stabilise compared to how it would progress without nitisinone. And it was the same thing in the SONIA 2 study, okay? So what we're doing with the registry is we have taken, thanks to Ranga, all of those questions that Ranga put together about your knees, your elbows and everything. You answer all those questions, and then that allows Ranga then to look at the score. So we have 70 patients already. Every year, if you answer all of those questions, for all those 70 patients, hopefully more, we will be able to export that anonymously into a spreadsheet and look overall at how the score is evolving for these patients, as well as for each individual patient. Do you see what I mean? So it's not like we will immediately be able to give you an answer about your AKU, but over time we will gather data. And the more and more patients we have, the stronger the evidence. So for instance, in Australia, if you get 10 patients on that in Australia, over 5 years, after 5 years, we can export that data for Australia and tell your clinicians, this is what the AKU Severity Score Index tells us for Australian patients over 5 years, okay? And then we can also extract those who are on nitisinone, those who are not, and compare those. Do you see what I mean? So with 70 patients, that's good, but what we need is hundreds and hundreds of patients. And that will then help you in your countries, once we've got enough patients, to export that data, and you will be able to go and tell your physicians and your regulators, this is the data we have for our patients in our country. And then we'll also be able to compare per country, and see how things, you see what I mean? That is what it's all about. It's about that data in a robust way. And it has to be done and the reason we went with Dendrite after 15 years is that we were getting quotes from companies quoting us hundreds of thousands of pounds to develop registries with all kinds of bells and whistles and fancy graphics and everything. It's like, that's not what we need. What we need is a really good database that is super compliant to all data regulation, okay, that has been, by a company that has been doing this for the NHS and loads of others over decades, and that's affordable for patient groups. And that's exactly what we found with these guys, and that's why I recommend them to all the other patient groups. So we did a crowdfunding campaign a few years ago. We raised £30,000 for the registry. That's what it cost us to develop it, which was about a tenth of the price that we were getting elsewhere. And now they charge us about 20% of that every year to maintain it. So you can see it's an absolute bargain for us as a patient group. So that's why what we tell you is every time you input the data, answer all the questions. Don't just go and do one page and think, oh, I've had enough of this. It'll take you time, answer all the questions, answer them accurately, and then we'll try and get these reminders that every year you go back. Because what you are doing there might not seem like much, but you are basically building the body of data to help all AKU patients as well as yourself. So it works as a knowledge tool, as a scientific tool, as an advocacy tool, and as a policy tool. Now, the French reimbursement agency, the Haute Autorité de Santé, when we spoke to them 3 years ago because they didn't want to reimburse nitisinone because they didn't understand, and eventually we convinced them to do it, one of their requests was to have a registry, and this is the kind of data we're developing for them. The other thing is also, we soon, at some point, once we've raised £1 million, which is not easy at the moment, we will do a study of nitisinone in children. And one of the things there will be the registry, because then we will want to see over time how the children evolve over 5, 10, 15, 20 years. Okay? Does that answer everyone's questions? Yes. Okay. So that's why it's really important. So on the language, the issue is always cost. We're a small charity, there's only 2 of us part-time, and it's always about cost. So we're trying to do it in Slovak, because there's 200 patients in Slovakia, and Richard Imrich, who is our key clinician there, is helping with the translations, then we'll do it. For Brazil, I think you'd need it in Portuguese, we can definitely look at that, it shouldn't be too hard, particularly now, you can just use any AIs to translate, and then you just make sure that you have someone with strong language skills and strong clinical skills to check it all and stuff, and then we'd work with Dendrite to translate it, into as many languages as possible, So we want to do that, yeah. So a few things. The next thing, people ask me about nitisinone, okay, and how to get it in your countries. So one thing I realised, I can't remember who I was speaking to, but about 12 years ago, I was at a meeting in Amsterdam from the Eurodis, the European Organisation of Rare Disorders. And this was just when we were trying to get, money to do the nitisinone studies and all that. And I can remember, I think it was the vice president of Eurodis who had, I think, a child with a rare disease. And she told me, Nick, you have to understand, the fight never ends. It never ends, Once your kids are diagnosed or you're diagnosed and all that, it never ends. Even when you get a drug approved, the fight never ends because it'll get approved in one country or Europe, but then you need to get it in all the other countries. Even once it is approved and reimbursed, you're even not sure it will continue to be reimbursed because there'll be a change in policy, some new minister of health or whatever, and they'll think, whatever, budget constraints. So the fight never ends. So you have to really understand that in your countries, you have to fight for this and you have to keep on fighting and advocating. We live in societies where people listen to those who shout the loudest. So you have to shout as loud as you can, and you have to arm yourself with data and with publications. So to those of you who are trying to get nitisinone approved in your countries, we are here to help. We can provide you with the publications, with the data, with all that kind of stuff to help. So 2 key things you need to do. If you don't have an AKU site in your country, you need to set one up, okay? So you need to register as a charity with your government and set one up. It's generally quite straightforward because the government and the companies prefer to speak to registered organisations. That's the first thing. The second thing, if you don't have any clinician or scientist who's advocating for you in your country, you need to find one. And the best way to find them is to go through your umbrella organisations for rare diseases. Most countries now have umbrella organisations for rare diseases, some national organisation for rare diseases. Speak to them, and through them try and find out how you can do things and how you can, really get people on board. That's the key thing. But you need to keep fighting and get your family members involved. And if you're parents with kids, as parents, you can be the best advocates for your kids because people will listen to you. Yeah. But nitisinone works, and it works really well. So we need to try, and it's now cheap. It's generic. And if any of you are struggling to get access to it, we're in touch with a generics company. And they are trying to get it approved by the FDA in the US, which will then be helpful for all countries because most countries follow what the FDA does. So I'm getting feedback on this thing. And the other thing is they have also another company they work with called Inceptua. And Inceptua are helping people in many developing countries access nitisinone for free. So just a couple of weeks ago, we were helping them actually get nitisinone to an AKU patient in South Sudan. We're helping them get access for Indonesia, in Bangladesh, and all that kind of stuff. speak to us, and and I met them actually last week at a meeting in Stockholm, the guys from Inceptua. They're really good guys, and they try and get people to have access to nitisinone sustainably for free, And if you're in kind of a Western country and you don't have access to it, I can still speak to them, and maybe, I don't know if they'll get it for free, but they'll find some ways of getting it to you and stuff. So there are mechanisms. Anyway, good. So a few other things. Badges, okay? On your way out, put your badges in the bowls, okay? And then that way when you come in tomorrow, we can give you your badges back and keep track of who is here, okay? Evaluation forms, remember, yeah, you scan this on your phone, you've got evaluation forms. Expenses, I hope everyone's understood. Email me your expenses and I'll get refunds as soon as possible. Just make sure they're very clearly filled in, particularly with your bank details and all that. Just after this, there's the focus group. So I think about 10, 11 people have signed up. Anybody else who wants to join, this is really important. This helps VitaFlow, who provide low protein kind of supplements and products and stuff. Really important when you're on nitisinone, and this helps them develop new products and also the content and all that other stuff. So that'll be over there. Drinks back here at 7:15, okay, from the bar. You'll have to pay for your drinks. Sorry, but however, when there's dinner at 7:45, there's wine and all that included, and dinner will be here. And then really, just to finish off, is to thank Leslie. There she is. Yeah. So Leslie started 12 years ago, in April 2012 it was, wasn't it? Yeah. It was just before the National Centre started in May or June, I think, 2012, wasn't it? That's quite a long time, actually. I mean, I had been working, we'd set up the AQ side in 2003, so I'd switched over full-time to AQ side just about a year or so before, and we just heard that we got funding for the National Centre, so we put out an ad and got quite a lot of applicants, and Leslie was head and shoulders the best, And it's been fantastic, Leslie. We've absolutely loved working with you. For 12 years, Leslie, I think, has been a superb advocate for AKU patients. The core of what Leslie has really always done is put the patient first and advocated for them, not just in the UK, but also internationally and stuff like that, So Leslie has now retired, still doing lots of work, for a number of causes and stuff like that, and still in touch with a lot of you and stuff. So we've got a little gift for you, Leslie, some flowers and some chocolates. And I'm very grateful because obviously I have two boys who have Alkaptonuria, and Leslie's done a lot really for them, And then we also have flowers for Natalie. So Natalie, who has been organising this whole conference.